and welcome to this Fireside chat with me. I'm Alex, and I'm here with Key,
Hey guys.
who is the CTO of Session, which is a private messaging app that tries to minimize metadata collection. So way back when Key co-authored the Session white paper, and he's been overseeing development of the application for 3 years. So we're going to talk a little bit about the experience of trying to make a privacy-preserving application, what some of the technical challenges are, and how things are going in that space.
Damn, it's been nearly 3 years. I was looking at the Google Play statistics thing, and it said our first app launch on Google Play, I think, was in February of 2020. So, but we also had the desktop Loki Messenger a long time before that as well. So
yeah, and there was sort of a pre-release build of Loki Messenger on Android, which was out in 2019.
Yeah,
if I remember correctly.
Yeah, we've come a long way since then. Let's just say that.
Yeah. So in a nutshell, for those who don't know, do you want to just give a quick overview of what Session is exactly?
Yeah, so it's, as you said, kind of in the introduction, it's a metadata minimized messenger, which focuses on a few key things. Mainly not having phone numbers, onion routing your messages, and then also using a decentralized network to store messages as well. So those are kind of our unique selling points when it comes to messaging systems. I mean, in terms of history, we're originally a fork of Signal, so we came out of that kind of lineage because we really liked what Signal was doing, and still like what they're doing as well. So yeah, we have kind of a history steeped with other encrypted messengers as well.
So I was actually, we've been looking back at the Session white paper recently because we're currently working on an updated version of it. But in the original white paper, it talks about the current state of play of private messaging applications and gives a bit of context. And even back in 2019, when that was originally written, there was a lot of sort of chatter about apps like Signal was starting to gain popularity. WhatsApp was really popular, had been bought out by Facebook. And increasingly we're seeing end-to-end encryption go around and this rise of this new class of application, which was the private messaging app, right? Not just a messaging app, but a private messaging app. So what actually spurred you to say, okay, well, we want to go a step further. So we like what Signal's doing, but there's more to do. And how did you identify those weaknesses?
Yeah, well, I think when people say private messaging app, actually what they're more talking about is secure messaging applications. That's how I would describe them. And they're mostly talking about the use of end-to-end encryption. So if you look at Signal or WhatsApp now, because they also implement the Signal protocol, what they're really doing is encrypting messages end-to-end, right? So the person who's relaying the messages in the middle can't see the contents that are being passed through them. But they're not necessarily so private, because what happens is when you connect to that middleman, which is usually the Signal server or the WhatsApp server, you're giving up your IP address, you're giving up the information about when you sent a message, you're giving up your phone number, you're giving up your email address potentially, and other types of metadata which are around that message. So when we looked at the landscape as to what was out there, really we saw more security-focused messengers at that point, and we wanted to actually make a private messenger which would also handle that metadata aspect. And that was also when the Edward Snowden leaks, around the time that the Edward Snowden's leaks came out, and the WikiLeaks stuff that showed that the US government at least had these massive programs like PRISM, where they were collecting massive amounts of metadata about who went to which websites and when, and they were able to use that metadata to work out things about individuals or collectives, and apply certain techniques, policing techniques, for example, or even kill people based on it in Afghanistan and Iraq based on metadata. So we were really interested in creating messengers that were not just secure, but also private on top of that, and looking at that metadata aspect.
Yeah. So as you said right at the beginning, we liked what Signal was doing and wanted to build on top of that. There were some key changes that we knew we wanted to make. And a big one, which you mentioned before, was having the decentralized server infrastructure. Turns out that decentralizing Signal is not a very easy task. And some things that work in a centralized context don't necessarily work very well in a decentralized context. Do you want to cover what some of those things were, why they didn't exactly work, and the changes that we made to make them work in a decentralized context?
Yeah, so I mean, a lot of the issues would come around reliability. So, when you don't have a centralized server that is always online, and always available, you don't necessarily have guarantees around whether messages are going to be delivered or not. So you'll send them to a server, you're not necessarily sure whether that server is going to be up or down. So you don't know whether your messages are going to be delivered or not. So the first I would say the first year, basically, we were building out the service node network, which is where all session messages are stored right now, on this network of 1,600 decentralized nodes run by, hundreds of different operators all around the world. And what we do is we kind of group them up into collections of swarms. So although there is a group of 1,600 nodes out there, we kind of group them into subgroups of I think it's about 5 to 7 nodes per subgroup. And then when you send a message, you're actually sending it to a swarm instead of an individual node. And a swarm being 5 to 7 nodes, if some of those nodes go offline, then you'll know that some of the other nodes still have a copy of your message. So that was kind of from the start that we knew that we needed to do that, because, Signal can rely on single servers or servers that are distributed but are still in a centralized kind of storage place. We had to rely more on, a server could go offline or online at any time, and there has to be swarms that will migrate into other swarms. If a couple of nodes leave a swarm, then it's going to get too small, so it needs to migrate into another swarm. So there were all of these complexities around building out the swarm network. That was probably the first thing we ran into. Then there was a lot of issues around the reliability of the Signal protocol in a decentralized setting. So we had to make some changes there and look at writing our own kind of simpler protocol, because we didn't have that message reliability. We didn't really have the ability to store pre-key bundles, which are used in the Signal protocol, on a server. And it just made more sense to kind of look at writing our own protocol, just because the network was so different. So yeah, we had to make several changes before we got things to a reliable state. And that's why, I was talking about, we launched 3 years ago, but that first kind of year was just working out reliability issues. We hadn't kind of launched something that was available to use by the public, in any successful way until quite recently, I would say.
Well, and there was, I don't remember exactly how long it was into Session's life cycle that this happened, but eventually we moved on to what is the Session protocol, which does differ from the Signal protocol, which we were originally using in a few ways. Do you want to cover a little bit more about what the Session protocol is and how it works? As you mentioned, it's a bit more lightweight, but do you want to go into a bit more detail?
Yeah, so I mean, the main component, or the main design goal of the Session protocol, is to be mostly stateless. So what Signal does when they're constructing messages that are sent between people is that they're constantly doing this Diffie-Hellman key exchange, and essentially that ensures that even if the channel is compromised, you can still come to an agreement on a new key to use with your partner. The issue with that in a decentralized context is that if you miss a message, or if messages come out of order in some circumstances, then that can mess up that Diffie-Hellman kind of key exchange that's occurring. So the Session protocol mainly aims to be stateless in terms of you're encrypting always for the same key on the recipient's device. So even if messages come out of order or some messages are dropped, you can always recover. You don't even need to recover the session. You can just kind of continue to use that end-to-end encryption that we have available in a more in a less reliable network conditioning. So yeah, I mean, and then we also looked at some of the properties that the Signal implementation was providing, and in our context they didn't make as much sense as well, because Session accounts are kind of more portable than Signal accounts. So when you have a Signal account, it's linked to your phone number, which is probably going to be a long-term identifier that you keep around for a long time, whereas Session accounts, because they just are generated as soon as you open the application and they're not tied to any identifier, they're not tied to an email address or a phone number, you can just generate them as you see fit. If you no longer want to be connected to a Session account, you just leave. There is no account, and after 14 days all of the messages are gone, and there's no sign up on a server or something like that. You can just create a new account. So when you take that into context, and you also take the reliability element into context, I think it really makes sense what we did to kind of improve the reliability of messages. And when we implemented the Session protocol, we saw downloads massively increase, and the reliability of the service increase too.
Yeah, it's interesting what you say about with Session IDs and the notion of the account. And in Session, the idea of an account doesn't really exist in the way that it does for traditional messengers or other messaging applications.
I think that confuses a lot of people as well.
Yeah, I think it does as well. And a lot of the time we've found ourselves kind of trying to, squeeze the idea of an account into the app because it is really familiar.
Yeah.
And, it's a framework that people understand, like, oh, I have an account and this is my account and people message me and I can log in on another device or whatever. But this doesn't really exist. And if you're not familiar with, public key encryption, then it is a bit confusing. But that's something we've been working around, and it's a deliberate design decision as well. Like you said, it makes things more portable, and you can kind of have it's almost a temporary account system, or you can instantly create a new session ID and drop the old one.
And it's completely permissionless as well. You don't have to talk to create a new account on session or to create a new key pair on session, which is what we call it internally. You don't need to talk to any server. You don't need to talk to any individual. You don't need to get permission from anyone. There's no sign up, put in your email or your phone number. It's just literally a cryptographic operation. You create a new key pair, and then if you sign a message with that key pair and send it to the network, the network doesn't even keep a record of your account. It just relays the message to the other person, and that's it. So it's a much kind of simpler idea of an account than you would have in a traditional messaging sense.
Yeah. I want to talk next about onion routing. So we've talked a little bit about decentralization, which goes hand in hand with onion routing. So people might be familiar with the idea of onion routing from Tor, or maybe even from Apple's private relay system, which they implemented a little while ago. It's currently in beta. But do you want to explain how Session's implementation of onion routing works and what purpose it actually serves?
Yeah, so the main thing that we're trying to control with onion routing is the user leaking their IP address to the decentralized network of nodes. And in a traditional messenger, this would be the user leaking their IP address to a centralized server, which would have a list of, hundreds of that. In Signal's case, they say that they don't keep logs, and same in WhatsApp case, they don't even say that they don't keep logs, but they have their servers will be connecting to users, so they will have a list in WhatsApp case of billions of IP addresses talking to their individual, or probably less than billions, but lots of IP addresses talking to their servers. And then also on the other side, you have a sender, which when they send a message, they'll be giving their IP address up to the server. And then when the receiver receives that message, WhatsApp servers will also know the IP address of the receiver. And if you also know the time at which they sent the message, then you can kind of work out very easily, that IP address sent the message, that IP address received the message at this time, and that ends up becoming a proxy to identify the individuals who are actually sending messages. So what we do in the onion routing kind of idea with Session is, instead of directly sending from your IP address to the server, we actually go through a number of hops. So the service node network is also an onion routing network. It stores messages, but it also onion routes them as well. So you'll talk to a random service node. That service node will talk to another random service node, another random service node, and then at the end, the storage server only sees that a random service node has sent a message. It doesn't see the user's IP address. This user's IP address sent a message. And that's the same on the receiving side as well. When you go and fetch a message, you go through a number of hops. We had this decentralized network architecture, but that wasn't enough for us. We wanted to ensure that the user's IP address, when they were sending and receiving messages, was also not exposed. So it's another part of kind of the metadata puzzle that we try to build to protect people. And IP address is just, as like with a phone number, that's a piece of metadata. An IP address, that's a piece of metadata. So we go through and try and remove every single piece of metadata from a message that we can.
Yeah, and it is really important. I think we've seen metadata from WhatsApp, I think specifically IP addresses used to de-anonymize whistleblowers and prosecute them in the US and possibly other parts of the world. It is really important. And actually brings me to my next point, which is that obviously the decentralization of Session brings a level of technical protection, whether that's from a malicious actor or whoever, but it also, I think, brings a level of regulatory protection. So the actual development team of Session is domiciled predominantly in Australia, which is a country that does have a bad track record when it comes to protections on encryption and protections on security and tech developers in the country, telecommunications, user privacy, things like that. A really bad track record, in fact. And often this gets brought up, but really for us, it's just another layer of justification for that decentralized architecture. So do you want to speak a little bit more about that?
Yeah, well, that's the thing. Like, if I was like a Signal or a WhatsApp or one of these centralized messaging services, and I was running a company in Australia, I would be very concerned, because essentially what you have with Signal and WhatsApp is you have even if the messages are trying to encrypt it. So even if the government was to come in and ask, okay, what is the contents on these servers, Signal and WhatsApp wouldn't be able to tell them necessarily, right? But they would be able to tell potentially the government services, these are the IP addresses which are connected to the servers. Or the government could come to them and say, hey, we want to run this black box in your server room. Don't ask us what it's about. We just run it there, and you can't do anything about it, essentially. This is the law. And then they just install one of those black boxes there, and all of the messages that are flowing through the server, they collect the metadata on them. So the IP address of the sender, what time they sent it, any other related information like who it's going to, the recipient of the message, for example. All of that would be stored in that kind of black box. The thing is, the Australian government can't really do that to us because we don't have any specialized view into the network. The people who run the service nodes, they're operators all around the world. So there's hundreds of operators. You can look at the service node map. There's 500 nodes in Germany or something, 500 nodes in the US, all across different states and all across different countries in Europe. So if the government comes to us and says, oh, we want to install a black box in your server rooms, well, I guess you could install it on our website server room, but that's that's kind of the only meaningful access that we have to the network. So we're in a much better position when it comes to not even having access to that data. And I think that's the best position to be in. It's not to have data but then limit it by legal liability or some contract that you've written with your customers. The best position to be in is just to not have the data at all, and that's kind of the position that we've put ourselves into in Australia here.
Yeah, and we've seen this situation play out a number of times. There's a famous quote by Edward Snowden about this, and he's speaking about his time when he was an intelligence analyst, and he said something along the lines of, well, message contents is nice to have, but the metadata tells a much more detailed story a lot of the time than the message contents do, and importantly, the metadata can't lie. The contents of messages could be misleading, but the metadata, is cold hard facts that and when you have a huge amount of it, you can paint this really high fidelity picture of a situation when you're doing analysis. So with that in mind, end-to-end encryption a lot of the time doesn't feel like enough, and security doesn't necessarily feel like enough, or it's protecting against a different kind of threat.
Yeah, I think end-to-end encryption is the first step that you should make, and it's in some ways it's the easiest step as well. The metadata stuff is much harder to control, but as you said, the metadata is where governments and despotic regimes and stuff, they're all going towards metadata right now because so much of the internet is becoming encrypted at this point. So it's really where I think companies need to start focusing more effort onto, and I guess that's what we're kind of trying to do at Session.
Yeah, so we're 3 years in now, and actually as we record this video, currently getting quite a lot of traction in Iran. So do you want to tell everybody a little bit more about what the situation is, how we've sort of reacted to it?
Yeah, so there's really big protests going on in Iran right now, I think related to the death of a young woman in a police station. But basically, we're seeing widespread internet censorship in Iran, and people are struggling to communicate outside of Iran or get information outside of Iran. So what people are doing, and I think they also have a sense that they want privacy and they want security when they're talking to their friends or organizing protests in large groups. So, just over the last 10 days or so, I think we've onboarded nearly 250,000 users across every client implementation that we have. And we're seeing like a huge influx in Farsi speakers as well in our open groups, and people just messaging us directly saying, thanks for building this application. I think the real issues that we're starting to run into now is censorship of the internet in Iran. So, if the internet is entirely turned off, then you can't use Session. That's where apps like Briar maybe come into more of their own because they do have local network capabilities. But even if you're in a more censored environment, but the internet is still turned on, we're trying to work out how we can operate better in those environments as well. But from what we've heard, Session's working really well in Iran to contact people and to set up large groups for protesting. So really happy to see that usage uptick in the last, kind of 2 weeks.
Yeah, so I remember speaking to somebody from the intelligence community or ex-intelligence community a couple of years back, and they sort of gave me this warning saying, yeah, look, governments aren't going to try and brute force your app or hack it. They're probably just going to try and intercept it before it even gets to users, whether that's by PR management and trying to make the app look bad, or releasing compromised versions of it to various app stores, or whether it's blocking the internet, things like that. That's probably the biggest risk factor that you're going to face. When you get as big as something like WhatsApp, obviously they can't really do that, but when you're small, they'll see the opportunity to squash you. And now that we're running into this censorship in Iran, primarily coming through things like being delisted from the Play Store and through slowdowns of the internet, that's obviously a challenge that we're going to be facing more and more. So what kind of strategies or technical tricks are there to try and get around that in the future?
So the distribution of the app is really tricky. I mean, most of the techniques which we focus on for getting apps into other countries where the internet is blocked is trying to host you can sign the app with developer keys, but you also need then for the person to understand those developer keys, and check the signatures and stuff, which is technically tricky. But mostly what we focus on is trying to get the app in through legitimate unblocked means. So for example, Iran probably doesn't have the ability to block all of Amazon's servers, just because they host so much of the internet, for example, or they don't have the ability to block all of Cloudflare's servers, right? So typically what happens is you try and host a copy of your APK or a copy of your software on one of those services where they cannot block that particular IP address range or that URL from being accessed. So we're seeing efforts like that with VPN distribution in Iran right now. A lot of them are using Amazon's S3 buckets, which are essentially these big buckets that are used for storage by millions of apps around the world. So they block that, then they would have issues with every single other applications that Iranians need to legitimately use to, conduct business and all of that stuff.
Yeah.
So those are some of the methods that you can use to get information in. And you can also use some of those methods in particular ways. There's this technique called domain fronting as well, which allows you to get information out where it looks like it's being sent to Amazon, but then really once it gets to Amazon, it's sent to the service node network, for example. And different VPNs are using different systems to do this. So I think really what we're looking at when we're looking at censorship is partnering with an organization that does this work every day, because it's probably a bit hard for us to, set up all of this infrastructure on our own. So we're looking into that now. And yeah, I mean, it's interesting as to how you cross that barrier, because, when you look at different countries, Iran might have a fairly sophisticated, model on how to block people from the internet, but it's nothing compared to China. China is the top, internet censor in the world, and they have gotten really advanced, sophisticated technology to do it. So that's always kind of the the best. If you can get past the Great Firewall of China, that's like the top tier, and then you go down to less resourced countries, and it becomes a bit easier. So it's always a cat and mouse game with these different countries for this.
Yeah, and other than censorship circumvention, what other future work is there for session? Obviously, as you've said just then, it's a cat and mouse game with the censorship circumvention, but it's also a cat and mouse game just generally when you're trying to do privacy preservation or highly secure technologies. What's coming up next in your eyes?
Yeah, so I mean, it's going to sound a little bit boring, but a lot of the stuff for a session is just features, like stuff that people have in other messaging applications that they want to have in session. So, we just added emoji reactions. This is not like a privacy or a security feature, right?
Yeah.
But people really love reacting to messages with emojis. And if your platform is a secure messenger, but it doesn't have similar, features to other messengers, the reality is, there's only a very small portion of users who will be willing to trade off all of their usability for privacy, right? So you need to have those usability features. But then on the privacy front, like there's a lot of new technology that we're looking at integrating right now. I talked about specifically like censorship resistant VPN technology that we could potentially partner with. We're still talking about that. It's still we're not exactly sure what we're going to do there. There's interesting network surveillance technologies. So, for example, right now we use onion routing, but there's a technique called mixed nets, which are more resistant to global adversaries who can see every connection point in the network. So we're looking at that. We're looking at different encryption techniques that we can use for messages to potentially get additional cryptographic properties that we don't currently have. Disappearing messages, we're changing how those work to make them more secure, or client-side features like being able to remotely wipe someone else's device, like your friend's device, for example. Say your friend is captured by someone and they want to wipe their session, but they don't have the ability to log into their session. You could wipe it on their behalf. So there's, at several different levels, there's new features that are coming out all of the time, and new features that we're looking into as well. So that comes on the client side, which was what I was talking about there, or the network side, or the storage side, or the encryption side. There's a lot to cover, and a lot of features that will come into session in the future.
There always are. I want to return to the first point you made, and you sort of said, oh, well, it's not that interesting, but mostly we're just working on features. I actually think there is a really interesting point to this, which is trying to build usability or a feature-rich application without collecting and exploiting user data. A lot of the time an app like Instagram, for example, has billions of data points that it will use to develop a new feature. But we obviously have to have a very different methodology because, first of all, we don't have that information about the people who are using the app, and we don't want it either. So how do we actually build these features in a privacy preserving way?
It's a kind of weird perspective to come from, because like most companies these days are trying to like optimize the amount of data points that they can collect for their applications. And look, we would love to be able to do that in a privacy preserving way, but it just like there are some techniques out there that you can use, but they just don't seem like they're worth kind of the hassle almost. Like you will have additional data even if you use these privacy enhancing techniques to gather data. So we just try as much as possible to not gather the data at all in a programmatic way. What we're leaning on more these days is like opt-in surveys and stuff. So we'll put out surveys, in the session app, like in the settings menu, that anyone can answer, or put them out on our social media or through email, but people don't have to answer them. If they want to deliver more information to us about how they use session, they can. It's up to them. But we try to like steer as much away as possible from like automatic data collection. Like automatic crash reports would provide a lot of data to us, but they're also very identifying. Like analytics on how people use the application. I mean, a lot of applications these days will have analytics about, how people go from screen to screen. Like, they press on this button, or they'll do an A/B test where they like provide some version of the application to someone and then the other version of the application to someone, and then they'll measure like how they interact with each level of messaging screen. We just can't really do that. Like it's so like it's very invasive for users, and there would be so much pushback against it that and it's against our philosophy as well. So yeah, we're really trying to lean more into the kind of the voluntary data collection stuff. So if people want to give their experience to us, they can.
Yeah, and I think that we've been doing the voluntary opt-in feedback and testing for it's probably been about a year now. And we've really started to see a community of people who are eager and voluntarily participating and providing feedback and making suggestions, as well as just a really dedicated community generally around the app who there's a constant discourse around, oh, we should do this or we should implement this. And of course, being open source, there are people who are literally going and doing it themselves and trying to build things and implement them. And in the end, maybe it's not as efficient as having 1 billion data points, but it does feel like a more holistic and obviously privacy preserving and therefore ethical way of developing an application, although it has introduced more bumps along the road over the last 3 years.
Yeah, definitely. I mean, if you're looking for an example of that, I would say our current disappearing messages refactor is probably one of the better examples. For example, we have customer support portal that people can submit issues to, and a lot of people were saying, they were raising issues about disappearing messages, why are they restored after 14 days when I restore my account? And basically, we've taken those suggestions through surveys and these support forms and just general chatting with users, and then we've started to implement a new way of doing disappearing messages, which won't run into the same issues. So that is a lot of what we kind of do at Session, is taking informal feedback from people who offer it voluntarily and then developing features that way, instead of we have this heat map data on which button is pressed the most in the application. Now we're going to design something, an A/B test it. We can't really do that, but we can do what you're talking about here, which is kind of the more informal method, which we still think is pretty effective.
Absolutely. So I think in terms of this chat, we've pretty much run out of time. But it was great chatting to you about all of this stuff. And of course, if anybody who's watching is interested in Session or wants to chat to Key about Session, he's always available to talk about it. So get in touch either via social media or send him a message on Session. I find that's generally actually the fastest way to get a response.
My ONS, or the way that you can look me up on Session, is just by typing Key Jeff into the section where you would put a session ID and you can send me a message. So
yeah. So thanks for listening, everybody. Thanks for your time today, Key. We'll see you around.
Thanks, guys.